за потрібною оптичною структурою, антибактеріальною і антираковими властивостями. Синтез каталітичних плівок на основі оксиду, змішаних оксидів і цих часток ми бачили в результаті фотокалістичних деградацій токсичних органічних сполук. Це той приклад, який ми отримали. Наночастки срібла та золота. Основна їхня риса в тому, що перше, синтез було зроблено досить дешево і легко фотохімічним методом, використовуючи фотокаталізатор, зроблений нами, і в вигляді плівки і демобілізованого катю органічного частки. Диоксид кремнію, який покриває частки золота, це срібла.
The main achievement is that we elaborate special stabilizer which prevents coagulation of nanoparticles, their growing, and agglomeration and oxidation. It's the main point. And silver and copper nanoparticles are very easy oxidized. In this case, they are saved during a very long time. And we used bimetallic composite stabilizer, bimetallic silver, gold on silica as well as in colloid state in form of alloy and coarse shell. This is diagram shows antimicrobial properties of silver nanoparticles against Escherichia coli, aeruginosis, Staphylococcus aureus, and fungi Candida albicans, and compare with the same activity of silver in form of ion, in ionic form, which usually is used in the medical practice. We can see that antibacterial activity is pretty high for all of microorganisms. And this table demonstrate antimicrobial activity in colloid silver in colloid state, and on the silica surface at extremely low concentration of noble metal. So it's nice results which have been done in accordance with test of by European standards. Antimicrobial activity of silver nanoparticles, stabilized silver nanoparticle in colloid state, is saved during 2 years. Remained even the same as fresh prepared. This work is protected, defended by 2 Ukrainian patents. Very shortly, very briefly, this demonstrated mechanism of action using a laser fluorescent microscope. That silver nanoparticle destroyed wall of bacteria cell. This picture demonstrates preferences of using of bimetallic nanoparticles. In case of treatment of carcinoma. I don't mention about anti-cancer activity individual nanoparticles. They have activity also, but bimetallic nanoparticles in form of alloy are more active. This diagram shows survival of experimental animals and tumor sized when we used this system. What is interesting that now it's very popular in the literature using of so-called mixing nanoparticles connected with amino acid and living organisms. And we can compare. We compare this activity using organic stabilizer for bimetallic nanoparticles and amino acid tryptophan. In this case, this is Lewis carcinoma injected to mice. This is liver sample of liver after action of bimetallic nanoparticles covered with sodium diethyl sulfate, surfactant, and covered with tryptophan. We can see that amount of metastasis is 45% less than in case of using of surfactant, and survival this part of experimental animals are better. In this case, after injection of uterine carcinoma, starting from 9th day, for this mouse, you have been used bimetallic composite as for the treatment, and the result is promising, it seems. What is important is that it is well known the enhanced Raman signal of molecule which are located near nanoparticle. This feature could be used for the creation of biosensor and biomarker. Raman signal is enhancement if molecule are located near on the defined distance between molecule and nanoparticle. We can compare Raman signal of tryptophan and tryptophan near nanoparticles of gold. So such systems, they are very stable. Tryptophan has here two functions for reduction of salt form of gold to the nanoparticle and stabilization. And it's potential biomarker for sensing, for imaging, for therapy, also diagnosis, and by this should be reduced drug doses, toxicity is low. We have this data all to characterize this picture. I have a lack of time. Okay, and time of patient treatment. We stabilized also very easy oxidized, very non-stable copper nanoparticle. They are more cheap than silver and gold, more available. So we use different, various stabilizer, and we have found out several chemical good stabilizers and stabilizers in form of amino acid and another compounds. So we can see that antimicrobial activity of copper nanoparticles stabilize it with colloids, colloid silica is pretty high also, comparable even sometimes higher than typical for silver nanoparticles. This work is in progress. Another part, very shortly, it's Zollsville production of titania-based photocatalysts, which are active under UV and under visible irradiation. Titania zinc oxide modified with silver gold, produced with transparent Zoll-gel precursor with typical SPR plasmon resonance absorption bands. This system produced via Zoll and deep coating technique. We produced transparent and very strong. Very strong adhesion to the silica carrier films under. Sorry. Okay. This is a scheme of destruction of tetracycline in the wastewater as an example. It is very stable compound, and we have full mineralization of this molecule in the wastewater after 19 minutes of irradiation. Advantages and innovation are shown in this table. A field of application is very high, very wide. In medicine, biology, food industry, packaging, antibacterial hygiene, covering for tables and instruments with high bacterial activity, and so on and so on. Next step, we would like to go to the textile issues and to polymeric films, to introduce nanoparticles and their combination to the polymeric carrier, and applied to enhance to produce biomarkers on the basic of nanoparticles with reduction toxicity. This is approximate cost of such work, because it's fundamental fundamental study, and we need a lot.
Это гривни, доллары, рубли.
Гривни.
Гривни, 250 гривен.
1,000. Look at this.
1,000.
Yeah. Contact information. Thank you very much.
Thank you. May I ask you a question? Antimicrobial activity of silver is very well known.
Yeah.
As well as antimicrobial activity of nanoparticles of silver is very well known. I'm sure you monitor the scientific literature. So what's new about silver and about antimicrobial activity of silver in your case?
Yeah. First of all, it's as we think.
Вы напрасно отвернули его, вам говорить не могу.
Okay. I think that what is new? What is new is, first of all, stabilization. I don't know more stable silver nanoparticle compare with we just produce it, because we found out binary stabilizer which absolutely don't prevent antimicrobial activity, being covering nanoparticles covering with this stabilizer. And we checked many times. It works very nice. It is stable 2 and more years. It's not so often case.
Okay, please. Іван Кирилович, будь ласка.
Скажіть, будь ласка, препарат в виде суспензии предполагается принимать перовс через рот?
I see. Yes, it's possible, because silica is biocompatible.
В кишечнике основная часть микроорганизмов очень полезна, без которой человек не может жить. Какая судьба их будет при воздействии вашего препарата, который содержит аргентум?
So what will be the action of your pharmaceutical, which contains silver and copper on the microorganism within the digestive tract of human. No, I'm ready only to say about the lab mice, not humans.
Если можно микрофоном.
Окей. По-русски можно говорить.
Пожалуйста.
Значит, ну как бы сказать,
the most important thing that toxicity is down to 50% if we stabilize the metal by amino acid, which is biocompatible. So tryptophan, and we also think about other amino acids and vitamins. What holds a nanoparticle and what can tie to it? Our main task is to look at the mechanism. How do they act? So toxicity is down by half. Okay, the question was a little bit different, but thank you. Okay, just one short question and very short answer. How do you prove that these are bimetallides? Maybe it's just a mixture of nanoparticles. That's a very smart question. The fact that it's that they are biometallides has been proven by two methods. Optical spectroscopy gives a direct answer, where SPRS, the full plasmic resonance of silver, where we see where there's gold and where silver and where's an alloy. It's a very simple method of controlling. And of course, electronic microscopy, because it makes us see where is a core shell and where's alloy.
The next speaker is